Welcome back to my channel, everyone. Sweet Tips here. And what we're going to do today is make some electrolyte from my silver cell. I'm going to use some silver bars that I purchased for making the electrolyte. Okay, we've got 967 grams of pure silver. And now I do not care for this kind of silver particularly because I'm not sure if what we really have here is silver. So I'm going to have to test each piece before we commit it to the acid. What I'm using here is called Schwartz's solution. I file into the corner of the metal and then apply a drop of this, and it turns blood red, and that tells me that this is pure silver. Schwartz's solution is potassium dichromate, about 1 gram of it dissolved in about 30 milliliters of 50-50 dilute nitric acid. Alright, I've tested all this silver and it's all authentic silver. Now what we'll do is transfer the silver into a beaker. I need a big one because it takes about 1.2 milliliters of 70% nitric acid and 1.2 milliliters of distilled water. So for that amount of silver, I'm going to need about 2 liters of liquid. Let's get that mark off of there. I got some carburetor spray here, and these markings that I add to these beakers, you can wipe them right off with some carburetor spray. Let's go out to the fume hood now with this. Here's our silver in our beaker, and what we'll do is we'll add about 1.2 liters of distilled water. I'm going to cover this up. I'm going to set this up on the heat now. The assay on this, according to this label, is 68 to 70%. It's ACS grade, but it doesn't have to be. You can use technical grade for this. I'm going to add 500 milliliters to a clean beaker. To start this off, what we'll do is take about maybe half of that and pour it right into our container that has our silver in it, about half of it, without adding any heat. Cover this up now and let this begin to react. Let me give this a little stir by shaking this up. And normally when we dissolve sterling silver, we'll expect to see a blue colored solution here because sterling silver has copper alloyed with it. This should be 999 fine silver, so it should be colorless when we get done, like water. And that reaction does not look very vigorous, so I'm going to pour in a little bit more of my nitric acid. I can always add more, and I can't take any back out if I overdo it here and we start foaming over to overflow the beaker. So it's best to add small amounts slowly. I'm applying some gentle heat. We'll start heating this up now and see if we can get all that silver to dissolve. I've added the charge of 500 milliliters of nitric. So we're going to go ahead and measure out another portion here. This time I'm going to go with 600. I'm going to add a little bit more distilled water just to make sure that we've got plenty of distilled water. A medium for the silver to dissolve into. Let's pour in a little bit more nitric acid. The trick is to get this all in here and get it in here safely without creating a boil over. And once we get all this nitric in there, boy oh boy, we should be able to dissolve all this silver. Here you can see all the silver bars have been dissolved. It only took 900 milliliters of nitric acid. You can see there's still excess nitric in that solution. So what I'm doing here is measuring out some of the pure silver crystal from my electrolytic silver cell. And we're going to use that to consume the rest of the excess nitric that's in the electrolyte. Earlier in the video I said it took about 1.2 milliliters of nitric acid to dissolve 1 gram of silver, and that figure was for sterling silver. I'm not working with sterling silver here, I'm working with pure silver. So 1.2 milliliters is way too much nitric. Here I've got excess nitric in the electrolyte after all the bars are gone. So in order to remedy that, I'm adding some pure silver crystal from my silver cell to consume the excess nitric. The color of this solution, when the reaction is complete, should be colorless. But if you notice it has a yellow tint to it, that means there's a whole bunch of excess nitric still in that solution. So I'll just keep adding silver crystal until the reaction ceases and all the fumes clear up in that beaker. This is a time lapse of the entire dissolve sequence. You can see it took about 7 hours to get everything fully prepped and the solution ready to be used in my electrolytic silver cell. We've got the electrolyte on a rolling boil. There's no fumes in there, and that tells me that every bit of the nitric acid has been consumed now. So we're going to pull this down off the heat. And if you notice, there's still a little bit of silver left down in the bottom of the beaker. You'll notice that the color of the electrolyte is a pale blue tint to it, which indicates that there's some copper in there. And since I used some of my own pure silver crystal in there, now I'm going to have to prove that it's not my crystal that has the copper in it. It was the silver bars that had copper in it. So we're going to dissolve a little bit of my pure silver crystal. I've added 100 milliliters of distilled water to about 90 grams of some of the pure silver crystal from my electrolytic silver cell. A little bit of copper in the electrolyte doesn't matter. In fact, there's one refiner on the gold refining forum, Gold Silver Pro, and he claims that a little bit of copper in the electrolyte is beneficial for the crystal growth in the silver cell. But since I used some of my crystal to make the electrolyte, now I got to prove that it ain't my crystal that's got copper in it. I've got 50 milliliters of nitric acid. We're going to go ahead and pour that right on in. And we're going to dissolve a sample of the silver crystal from my electrolyte separately and see what color we get out of that. Now let's go ahead and set this up on the heat and cover it up, and we'll dissolve a sample of my pure silver crystal by itself, see what color it produces. In the meantime, I'm going to add some distilled water to this. This is about 1.3 kilos of pure silver dissolved in just about 1,500 milliliters of liquid. So I'm going to add some distilled water, because if I let this cool off, it'll form silver nitrate crystals. So I'm going to help it, prevent it from doing that by adding a little bit of water to this. It's important to notice that there's still some silver down on the bottom of this beaker that has not dissolved. Yet while it was boiling, there were no fumes up here, which indicates that all the available free nitric acid has been consumed by the reaction. And the reason that's important is because we do not want a high level of free nitric acid in our electrolyte. In the impure silver that we're going to be feeding in to the anode basket, we may have some palladium in that impure silver. Palladium is soluble in nitric acid. So if we've got a whole bunch of free nitric in our electrolyte, then what will happen is it will tend to dissolve the palladium in the anode basket, and then that palladium will leach down into the silver cell. Palladium is about 80 times more valuable than silver. So if we contaminate our pure silver crystal with palladium, when we go to sell the silver, we're going to be selling palladium at the price of silver. So I can tell if palladium has leached into my electrolyte, because the electrolyte will turn green. In refining, we can tell a lot about the purity of our metal when we dissolve it in acid, what color the solution is after we get done with that reaction. And if we had any copper in this pure silver crystal, then I would expect that solution to take on a bluish tint or blue color to it. However, if it's high purity silver, it'll be colorless with no color indication of any other kinds of metals present. Colorless liquid is what we want when we dissolve pure silver. This reaction is complete. There's no more fumes in here. This is a sample of my pure silver crystal from my silver cell. You can see it's colorless like water. And I did this to prove that the color that we see in this beaker here came from those pure silver bars. That's copper in there. So those 999 fine silver bars had a little bit of copper in them. The copper did not come from my pure silver. It's clear and colorless like water. I've got the electrolyte filtered now. So what we'll do is we'll pull this funnel off of here. Stick it back out of the way. I'm going to take our electrolyte over here to my silver cell. We've got almost 2,000 liters here, there's 1,200 grams of silver dissolved in here. So if I put 1,000 liters of this liquid into my silver cell, I'll have a solution that contains 600 grams of pure silver with 1 liter of liquid. So let's go ahead and put 1,000 milliliters of our solution that contains 1,200 grams of pure silver. I'm going to put 1,000 milliliters of it in this stainless steel bowl. Alright, I think we've got 1,000 milliliters left in here. So there's about roughly 600 grams of silver in this solution in this bottle, and 600 grams of silver dissolved in that solution in the silver cell. Got 600 grams of silver in here. Now I'm going to take some distilled water and top this up to about 3.5 liters of liquid. We're diluting the silver nitrate solution so that we're creating a electrolyte that contains about 150 grams of pure silver dissolved in a liter of liquid. I'll save this solution here and we'll use it in my second silver cell. There's enough there to make the electrolyte for my second silver cell. For now, what we'll do is put the cover on this one. When I refine gold, I use sterling silver to inquart the gold. Then I pull the sterling silver back out with hot dilute nitric boils. I recover that silver and then cement it on copper. And this is a 2.5 gallon bucket full of cement silver. And then what I do with that is I melt it and form these granules. This is impure silver made by melting this cement silver and pouring it into water. And it forms these granules. That's about 98 to 99% pure silver there. It's real ugly because that 1% copper reacts with the atmosphere and creates that ugly appearance to it, but that's about 99% silver there. And so we run this through an anode basket in the silver cell, and then we convert this to pure silver crystal. I harvest the pure silver crystal, and that's what this is from a previous run of the silver cell. And then once we get it all rinsed off, I get pure silver crystal like this in this container, and that's what our pure silver crystal will look like when we're done. It starts with this and we end up with this. This is just a Tupperware cup with some holes drilled in it. I've got a Dacron filter in here. Here's the filter that I'm using. It's a Craftsman vacuum cleaner filter bag. And I just stuff it in here and then put that little retainer ring on it. And now what we'll do is we'll charge this thing up with some of this impure silver. Now what we'll do is drop our anode basket down into the electrolyte. The bottom of it will be submerged in the electrolyte and make contact with the impure silver that's in this anode filter. I've got the silver cell all configured now. This is our electrolyte down in a stainless steel bowl. And I've got a stirring rod that I use to stir this up. And what will happen is we've got a electrode bar sitting on top of the impure silver in the anode filter basket, and it's connected to the positive side of a DC power supply. The negative side is connected to the cathode connection, which the cathode is the stainless steel bowl. I've just got it hooked on there so that we complete a circuit, and we turn the electricity on. We pass a current through this impure silver. It dissolves the silver. The silver passes down through the electrolyte and plates out on the inside of this stainless bowl as absolutely high purity silver, just like you see here. So let's go ahead and energize this now. We run this thing at 3.5 volts DC, and you can see the amperage is climbing there as the electrolyte finds its way through that filter and comes in contact with the impure silver. And after about a week and a half, what we'll have is about 1.5 kilos of pure silver in here that will look just like this. And then once we rinse all the electrolyte off of it and dry it out, it will look just like this. About 1.5 kilos of high purity silver in a week and a half. As the cell operates, what I'll do is I'll feed more of the impure silver into the anode filter basket, because as the cell operates, that stuff dissolves and that level will drop, and then I'll need to add more impure silver into the anode basket as the cell operates. So what we're doing is we're converting the impure silver into high purity silver crystal using this electrolytic silver cell. Okay, that will conclude the video. Thank you for watching.